Welcome to QuexBook Learning. Now, what is the limit of the function x squared plus 1 as x approaches to 1? We need to find the limit of this polynomial function, and the first thing that we should try to do is direct substitution. Plug in 1 to the equation, and if we don't get 0 in the denominator, then it should be fine. So in this case, there's no fraction, so there's no need to worry, so we can use direct substitution right away. Let's plug in 1 to the function. We'll have 1 squared plus 1, and 1 squared is 1, plus 1 is 2. Therefore, the limit of this function is 2. As you can see, using direct substitution is a nice technique in evaluating limits, as long as you will not get any 0 in the denominator, because it makes the function undefined, or it does not gives you a specific value. So how about our next example? Let's try to evaluate this limit of x squared minus 4 over x minus 2 as x approaches to 2. Now, using direct substitution, let us check the denominator if it will give us a 0. Let's try to plug in 2. In the denominator, we have x minus 2. So plugging in 2 to the value of x, we'll have 2 minus 2, which is obviously a 0. Since our denominator is 0, it makes our function undefined, meaning we need to consider other ways of evaluating this limit. One way to evaluate this is to use values closer to 2, like plugging in 1.9, 1.99, or 2.01 or 2.001. So you can check out our past discussion about this technique, but in this video, we will introduce to you a new way of solving limits. So one method to solve limits is by factoring. Now looking back to our function, we have the limit of x squared minus 4 over x minus 2 as x approaches to 2. So we can factor the numerator. Factor x squared minus 4, so we'll be having x minus 2 and x plus 2. For the denominator, there's nothing to factor, so let's simplify our function. Since we have x minus 2 in both numerator and denominator, we can divide them or cancel them out. Dividing x minus 2 in the top and x minus 2 in the bottom gives you 1. So our remaining function will be x plus 2. Now, we can use direct substitution. Plug in 2 to the equation, we'll have 2 plus 2 is 4. Therefore, the limit of our function is 4. Now for our next example, let's try to evaluate the limit of the function 5x over x squared plus 2x as x approaches to 0. Using direct substitution, check the denominator again if it will give us a 0. Now let's try to plug in 0. We have 0 squared plus 2 times 0, and 0 squared is 0 while 2 times 0 is 0. Since our denominator is 0, it makes our function undefined. Let's try to evaluate this limit by factoring. We have the limit of 5x over x squared plus 2x. Now, there's nothing to factor in the numerator, but in the denominator, we can take out the common term or the GCF or the greatest common factor, which is x. So if we take out x, we'll be having or we'll be left with x plus 2. Notice that we can cancel the x variable. So we'll be left with the limit of 5 over x plus 2. Now we can use direct substitution. Plug in 0 to the remaining function, we'll have 5 over 0 plus 2. 0 plus 2 is 2. Therefore, the limit of our function is 5 over 2. Now, how about for this next example? Evaluate the limit of the function x squared plus 3x minus 10 divided by x minus 2 as x approaches to 2. Now, if we plug in 2 to the denominator, we'll have 2 minus 2, which is 0. Since our denominator is 0, it makes our function undefined. Let's evaluate it by factoring. We have the limit of x squared plus 3x minus 10 over x minus 2. Notice that in the numerator, we have a trinomial. Now to factor this, find two numbers that multiply to negative 10 but adds up to 3. So what are the two numbers that multiply to negative 10? So we can try 5 and negative 2 and negative 5 and 2. If we add these numbers, so we have 5 plus negative 2 is 3, while negative 5 plus 2 is negative 3. Since our middle term is 3, obviously the factor that we are looking for is 5 and negative 2. Therefore, x squared plus 3x minus 10 can be factored as x plus 5 times x minus 2. So let us rewrite our limit. We have now x plus 5 times x minus 2 over x minus 2. Notice that we can cancel out x minus 2. So we'll be left with the limit of x plus 5 as x approaches to 2. Now we can use direct substitution. Plug in 2 to the equation. We'll have 2 plus 5 is 7. Therefore, the limit of our function is 7. So that's it for our lesson, and see you on our next learning videos. Enjoy learning!